y equal to x square. Okay, so let us see this, how much we'll get. So implies, so we have taken y equal to x square here, implies we need to find derivative of y also, because in equation 1 we are having y and dy also. So differentiate with respect to y. So you'll get dy by dx is equal to 2x. Implies dy. You'll get it as 2x dx. Okay. So substitute this value y equal to x square and dy equal to 2x dx. Okay. In equation 1. So from equation 1, what you'll get means f dot dr is equal to, and substituting y equal to x square here. So x into x square plus x square whole square. Okay. So into dx plus x square into dy. dy value is 2x dx. Okay. So this one is equal to, how much you'll get, x cube plus here this one you'll get x power 4. Okay, sorry, next plus 2x cube into dx. Okay, so this one is equal to 3x cube plus x power 4 dx. Okay, so we got f dot dr value as this much. Now integrate on both sides. So you'll get f dot dr. We have taken integration along y equal to x square curve. Okay, so this y is equal to integral 3x cube plus x power 4 dx. Okay, so but the integration through this curve is how much? We got the point as 1, 1. Okay, so x value ranges from 0 to here 1. So write the limits as 0 to 1. So how much you'll get? 3 into x power 4 by 4 plus x power 5 by 5. Having the limits 0 to 1. So this one is equal to 3 by 4 plus 5 by 4. Okay, sorry. 3 by 4 plus 1 by 5. If you substitute x equal to 1 here, minus 0 you'll get. So what is the this one? Fraction of this? 3 by 4 plus this one means LCM is 20. 15 plus 4 will get. So that means 19 by 20. Fine. So we got integral f dot dr over y equal to x square is 19 by 20. F dot dr over the integral y equal to x square is 19 by 20. So make a note of it and take this equation as equation 2. Okay. Now we need to find the integration along y equal to x line. Okay. So but here once you have reaching 0 to a, that means origin to a, next a to origin again you have to come out. Okay. So second part of the question is integration along y equal to x line. Okay, so that implies we have taken x equal to, sorry, y equal to x. Implies if you differentiate with respect to y or with respect to x, what happens? Dy by dx is equal to 1. Implies dy is equal to dx. I have sent this dx to that side. Okay. So when y equal to x, you got dx equal to dy. Now your wish whether you want to convert f dot dr in terms of x or y. Okay. So which one we want to find? F dot dr. This is from equation 1. Which one we want to convert? Whether you want to convert f dot dr into y variable or x variable?
X variable.
X variable. So substitute y equal to x here. So x into x plus y square is there. That means you have taken y equal to x. So you'll get x square into dx plus x square dy. So x square dy value is nothing but dx. Okay. So f dot dr is equal to 2x square, total 3x square will get 3x square, having the limits we have 3x square dx will get. Now apply integration on both sides. So integral f dot dr is equal to 3 integral x square dx. What are the x limits? We have to check here. So x varying from 1 to 0 here. So we are taking from a point to origin. So limits vary from 1 to 0. So here 1 to 0. So if we want to change the limits, so take minus before the integral so that the limits will change reverse. 0 to 1 x square dx. Okay. So if you apply integral, how much you'll get? Minus 3 into x cube by 3, having the limits from 0 to 1. So 3 get cancelled. This one is equal to, if you apply limit, minus 1 cube, this is nothing but minus 1 you'll get. Okay. So integral f dot dr over the curve y equal to x, we got it as minus 1. Okay. So implies we need to calculate overall curve region. Okay. So that means overall the curve C f dot dr is nothing but you need to add these previous two integrals. So that means integral f dot dr along y equal to x square plus integral y equal to x f dot dr. Okay, so this one is equal to how much you'll get? This is 19 by 20. Okay, minus 1 you got. Okay, so this one is equal to how much you'll get? Minus 1 by 20.
20.
Okay, minus 1 by 20. So therefore, integral around C f dot dr value, you got it as minus 1 by 20. So make a note of this one. Okay. Now we have found the answer by line integral. Now the same value you should get by surface integral by using Green's theorem. So this is half question. Now by Green's theorem, what does the Green's theorem will say? Integral m dx plus n dy is equal to integral of dou n by dou x minus dou m by dou y dx dy. Okay, so here what is m? We'll check. M is nothing but dx quotient. So from equation 1 you check xy plus y square. Xy plus y square. Next, similarly, n is nothing but x square. Okay, so implies dou m by dou y. You'll get x plus 2y. Similarly, dou n by dou x is equal to 2x. Okay, so now we need to find double integral. This is double integral over a region R. Okay, so let us see. Now double integral over a region R dou n by dou x minus dou m by dou y dx dy is equal to integral of, here how much you got, dou m by dou y. So dou n by dou x, you got 2x minus x plus 2y dx dy or dy dx, anything is fine. Okay, so now we need to write the limits for this. So to find the limits for this, first let us simplify the integrand. This is over a region R, you can put. So 2x minus x, you'll get x minus 2y dy. Now I have to write the limits. So how to write the limits means, again rewrite this one curve. So this is x square curve and this is y equal to x line. Okay, so this point, intersection point is 1 comma 1. Okay, origin, and this point I named it as A. Okay, now dx dy I'll write here. Now if you write dx dy, what is the outer integral? Y variable. Okay, for a y variable, what are the limits in terms of numbers?
0 to 1.
Okay, so 0 to 1 you'll get. So 0 to 1. Okay, now dx you are taking. Dx you are taking means take horizontal direction. So in horizontal direction, what is the first curve?
Y.
So I'll get x equal to y. So x equal to y. Next, what is the next one?
Root y.
So you'll get root y. X equal to root y. Okay. Suppose if you are writing dy dx, then you will write y in terms of x. So limits will be y in terms of x. Since here dx is there, you will write x in terms of y. Okay. So this one is equal to
Down it must be root y, no, sir. Limit. Limit, sir. Root y to y, no, sir. Why it is y to root y?
That is what I said, na. Here horizontal manner you have to check. In horizontal direction. First curve is what? This line, right? First curve you have to check.
Yes, sir,
In
okay.
horizontal direction. First curve is line. Next we are getting this curve. So that's why y to root y will get. Suppose you are checking in vertical direction. At that time you will get root y to y. Because if you are checking in this direction, it is first to y equal to x square, that means x equal to root y. Next here also x equal to y. So we are checking in horizontal direction, not vertical direction. Clear? So this one is equal to integral 0 to 1. Okay, apply the limits with respect to x. So integrate first, x square by 2 minus 2xy. Limits are from y to root y dy. So this one equal to integral 0 to 1. X square means root y whole square, that means y by 2 you'll get, minus 2 into root y. So root y into y. This can be written as y power
3 by 2.
1 by 2 plus 1. So that means y power 3 by 2. Okay. Next, minus y square by 2 will get minus of minus will get plus, substitute y. So you'll get 2y square into dy. So this one is equal to integral 0 to 1. Okay. Y by 2 minus y power 3 by 2 minus, if you take LCM for this y square terms, what happens? 4y square minus y square. So you'll get plus 3y square by 2. 3y square by 2 into dy. Okay. Now we can perform integration for this. Okay. Let us perform integration for this. So how much you'll get? We'll check. Okay. So here 1 by 2 integration of y is y square by 2 minus 2 into y power 3 by 2 plus 1 by 3 by 2 plus 1. Next plus 3 by 2 into y cube by 3. Okay. So having the limits 0 to 1. Okay. So apply the limits. How much you'll get? We'll check. So here 1 by 4 you got. So y square by 4 you'll get minus here 5 by 2 you'll get. If you take reverse in the second term, so you'll get 4 by 5 you'll get y power 5 by 2 plus 3 by 2, that means here 3 get cancelled,
Y cube by 2.
Y cube by 2. Here the limits ranges from 0 to 1. So apply the limits 1. So 1 square is 1. So 1 by 4 minus 4 by 5 plus 1 by 2. So this one is equal to, so LCM is 20. Here 5 minus 16. Here plus 10. So 10 plus 5, 15 minus 16. So we'll get minus 1 by 20.
7 by
10 plus 5, 15. 15 minus 16. 16. So 15 minus 16 is minus 1 by 20. So implies double integral dou n by dou x minus dou m by dou y dx dy over a given region R, we got it as minus 1 by 20. Okay. So previous also we got integral m dx plus n dy. So this is the given equation. Correct. So both has been satisfied. So implies Green's theorem is verified. Verified. So in this way you have to write the answer. Fine. Any doubts? Let's check it once. We'll go for next one. Fine. You go for next one.
Sir, once previous slide.
Now,
Sir, their limits you see it seems once.
huh? Limits.
Left hand side.
Okay.
Last third step.
Uh,
How 1 to 0?
so 1 to 0 means here, if you observe this diagram, okay, here only I'll explain. Okay. This is y equal to x square and this is y equal to x. Okay. First integral what where we found origin to a point. So that means in this direction you have taken. Okay. Next from A to origin you have to travel to complete this area. Okay. Since we are doing in vector quantity, direction is also most important. So from which point to which point we are moving. Okay. So to complete this region, we have to move from A to origin. Okay. Suppose if you are taking origin to A, you are taking negative direction for it. So to complete one bounded region. Okay. So from A to 1, what is the y value? Sorry, what is x value? 1, 0, 1, 1 here. So here 0, 0. So here starting point we have taken is A. So 1 to 0 we got. Clear? Because of this direction, it has been changed reversely. Clear? If you want, you can check. First, you can go in this direction and this come again in this direction. That is also fine. That means for first integral you have to do it for y equal to x and next integral you have to do it for y equal to x square. That also will work out. Clear? Is it fine? Doubt got clear? Eastern? Fine. Okay, we'll move for next one. So here, verify Green's theorem.
Sir, once go back to the last slide, sir.
Yes, this one.
Yes,
Take
sir.
a
Thank you,
snap
sir.
of it. Solution. So here we need to verify again Green's theorem for this integral x square plus y square dx plus 3x square y dy around the circle. Okay, in positive sense they have said. So let us see what is it. Okay, so given f dot dr is equal to this integrand you have to write, that means x square plus y square dx plus 3x square y dy. Okay, so after this take this equation as 1 and he is asking to find integral over a circled curve. Okay, so this is x square plus y square is equal to 4. So it means what is the radius? It is 2, right?
2.
So circle equation is x square plus y square equal to a square, which is passing through origin. Whose the center is origin. So this is a standard equation. So whose the radius is a square here, that means 2 square you can write. So radius is 2 here. Okay. Now write the given curve. So given curve is x square plus y square equal to 4. Okay. So if you want to do like previous problem, so what we need to do, we have to find y equal to something. That means 4 minus x square. So root you will get. Okay. So that means we have to substitute y equal to this value in this equation. So you can substitute, but what is the problem is nothing but if you substitute this value in this equation, what happens? Then we have to, integration will be difficult. So to avoid that integration, what we need to do, we have to take parametric equations for x and y, so that you'll get easy integration for it. Okay. So how to take parametric equation for this? Again,
2 cos theta, 2 sin theta.
yes, already we have did for one time. So you can take x equal to 2 cos theta and y equal to 2 sin theta. Okay, that means completely you are introducing one variable. X is also one variable and y is also one variable, so that one new variable will be generated for f dot r. Okay, so here dx is also there, dy is also there. So you have to differentiate with respect to theta here. So here variable available is theta. So this is not like compulsory. Theta is not compulsory. Okay, you can take it as cos t, sin t. Any variable is fine. Okay. So dx by d theta is equal to minus 2 sin theta d theta. You'll get this much with respect to theta you're doing. Similarly, dy by d theta equal to 2 cos theta. Okay. Now send this d theta to this side. Okay. So how much you'll get? Dx is equal to minus 2 sin theta d theta, comma, dy is equal to 2 cos theta d theta. Okay. So now what I am going to do is I am going to substitute these x values and dx values in equation 1. Okay. So implies f dot dr is equal to, what happens if you substitute in place of x, you'll get 4, because cos square theta, if you want to write, I can write it. So you'll get 4 cos square theta plus 4 sin square theta into, here dx value is minus 2 sin theta d theta. Next plus 3x square. 3x square means 4 cos square theta. Next into y. Y means 2 sin theta into dy. Dy is 2 cos theta d theta. 2 cos theta d theta. Okay, so this much we have to do. So let us write simplified version of f dot dr. So how much you'll get? Here cos square theta plus sin square theta is 1. So if you take 4 common, you'll get 4 into 1 into 2. Okay, this is into. So I'll get overall minus 8 sin theta d theta you'll get, minus 8 sin theta d theta. Next, this d theta I am taking at the end. So I'll get plus here.
48 cos cube theta sin theta.
48 cos square
Cube cos cube theta.
Cos cube
Theta d theta.
sin theta d theta.
Sin theta.
Okay, 48 cos cube theta sin theta. Okay, now we take this function in terms of brackets. Now if you apply integrals, what happens? Let us see. So integral f dot dr is equal to minus 8 sin theta, minus 8 into integral sin theta d theta plus 48 integral cos cube theta sin theta d theta. Okay, so this one is equal to minus 8 into what are the limits here? Limits are from 0 to complete circle, right? What will be the angle? 360. Correct. 0 to 360. 360 is nothing but 2 pi. Here also 0 to 2 pi. Okay. Now here sin theta means integration of sin theta. You'll get minus cos theta. Okay. So 0 to 2 pi. Plus 48. Okay, so this one how will you do? Integration of here I can write integration of f of x whole power n into f dash of x dx. Okay, so this is nothing but f of x whole power n plus 1 by n plus 1 will get. Okay. So this formula I am going to apply here. So what will be f dash of x here? Here f of x is nothing but cos x. F dash of x is nothing but minus sin x. Okay. So that means you have to write this sin x as minus of minus. So at that time you will get here in front of 48 you will get minus 48. Okay, so how much will get? Cos power 4 theta divided by 4, having the limits from 0 to 2 pi. So this one is equal to minus of minus, you'll get 8 into, apply the limits, cos 2 pi. So when n is even, so this value will be 1. Cos 0. Cos 0 value is 1 again. Cos 0, 1 again. Minus 48 into cos 2 pi. Again 1 power 4 minus cos 0. Again 1 power 4. Divided by 4 will get. So 1 minus 1, 0. So this will vanish and this also will vanish. So answer is 0. So integral f dot dr value, you got it as 0. Okay. So this is for rough work. You can note it. Next, we have to prove this by Green's theorem. Okay. So let us see. Is any doubts here? All right.
So now minus 48.
Here. So here, according to this formula, what we got is f of x must be cos theta. That means you have taken this as cos theta. Okay. So f dash of x must be minus sin theta. Then only you can apply this integral. Okay. So plus sin theta, I have taken it as like this. Minus 48 integral cos cube theta into minus sin theta, because f dash of x here is minus sin theta d theta. Clear? So if you apply this integral, you will get this much. So that's why you will get minus outside. Getting? while applying the integral value, we have to put minus here. Then only this equation will be balanced. So if you want, you can note this. Fine? Is it fine?
Yes, sir.
Okay. Next, we'll prove by Green's theorem. Okay. By Green's theorem,
Sir, once
Yes, sir.
show the previous slide.
1 minute. Yes. Fine. Notes I will send, don't worry. So just it will getting time. Okay. So by Green's theorem, what does it say? Integral m dx plus n dy is equal to integral of dou n by dou x minus dou m by dou y into dx dy. Okay, so this one is equal to how much you'll get? This is double integral over a region R. So now we need to find the surface integral. So for that sake, first we need to find what is m and what is n. So m is equal to dx quotient in equation 1. So dx quotient in equation 1 is x square plus y square. Next, n value is 3x square y. Okay, dy quotient. So implies dou m by dou y is equal to 2y you'll get. Next to dou n by dou x is equal to 6xy. Okay, so implies dou n by dou x minus dou m by dou y is equal to 6xy minus 2y. Okay, so implies now find the double integral over this one, dou n by dou x minus dou m by dou y dx dy. This one is equal to double integral 6xy minus 2y dx dy. Now you need to find the limits. If you want to find the limits, again draw the diagram. It's a circle, right? So what is the radius here? That means this radius is 2, this length also will be 2. Okay. So this length is also 2 and this length is also 2 because radius is same over the axes. Okay. So now what is the question is, what are the limits for y? Because y is the outer integral. We have to tell in terms of numbers. Where does y moves from?
-2 to 2.
Yes. So this is x-axis and this is y-axis. And if it is coming down means minus 2, here plus 2 on axis. Okay, so minus 2 to 2. Where does x moves from? Which curve to which curve? In horizontal direction you have to check it. So that means left side part of the circle to right side part of the circle. So that means this complete region you are finding. Correct. Okay, so left side part, sorry. Okay, so left side part of the circle to right side part of the circle. So how to write left side part of the circle? By writing this, you can check it. X square plus y square equal to 4. From here you are finding x value. So that means x square is equal to 4 minus y square. So x is equal to plus or minus root 4 minus y square. So left side means, left side of x-axis means negative. Right side of the x-axis means positive. So that means minus root 4 minus y square to plus root 4 minus y square. So in this way you will find the limits for circle. Okay. Now we will apply the integration. Integral minus 2 to 2. First integrate with respect to x. So I will get 6y x square by 2 minus 2xy. Apply the limits. Minus root 4 minus y square to plus root 4 minus y square dy. Okay. So this one is equal to integral minus 2 to 2. So 2 ones, 2 3s will get. So that means 3 x square y will get. Okay. Minus 2xy, and the limits minus root 4 minus y square to plus root 4 minus y square. So this one is equal to integral minus 2 to 2, or I can write in the next line. Integral minus 2 to 2. Okay. So substitute this one. How much you'll get? 3y into root of 4 minus y square whole power 2. So that means root get cancelled. 4 minus y square. Okay. Minus 2y into root of 4 minus y square. Okay. So this is upper limit minus lower limit. So lower limit is how much? 3y into minus of root 4 minus y square whole square. So you'll get plus 4 minus y square whole square. So you'll get positive here. Next, negative of, if you apply this, how much you'll get? Plus. Minus of minus plus 2y root 4 minus y square. Okay. Fine.
Yes, sir.
So which one will get cancelled now?
3y into 4 minus y square.
So these get cancelled. So here also you'll get cancelled. So how much you'll get?
Minus 4y into root 4 minus y square.
Minus of this. Here we'll get plus. So again minus 4y. Minus 4y root of 4 minus y square.
Y square. 3y.
dy. Okay. So you need to perform integration for this. How you will do is nothing but suppose if you take f of x is equal to 4 minus x square, what will be f dash of x? Minus 2x, right?
Minus 2x.
Minus 2x. So it is of the form f of x whole power n into f dash of x dx. So like previous. So this is can be written as f of x whole power n plus 1 by n plus 1. Okay. So this one is equal to, so how much you can write? Minus 2 to 2. So here, this can be written as 2 into 2y. Okay. So I have written 1, 2 outside, minus 2y, 4 minus y square. I am taking it as f of x whole power 1 by 2 dy. So in this manner I have written this. Now apply the limit. Sorry, apply the integration. So I'll get 4 minus y square whole power 1 by 2 plus 1. So that means 3 by 2 divided by 3 by 2. Having the limits from 0 to, having the limits from minus 2 to 2. Okay. So how much you'll get? We'll check once. So this one is equal to 2 into 3 by 2 can be written as 2 by 3 again here. 4 minus y square minus 2 to 2. So I'll get 4 by 3. If you apply 2 here, what happens? 4 minus
4 minus 4.
4. Okay, minus 4 by 3. 4 minus 4 again. So you got cancel. So again you got 0. Okay. So implies double integral dou n by dou x minus dou m by dou y. Okay. So over a region R, we got it as 0, and which is also equal to line integral of m dx plus n dy, which is the given integral. So both the integrals we got it as 0. So implies Green's theorem is verified.